Let me ask you a question. What if coding wasn't really about computers at all? Not about screens or keyboards or complex lines of text? What if instead it was all about hopping and mooing and even making a big splat sound? Yeah, some of the very first games we ever played. It might sound a little out there, but it's totally true. And in this explainer, we're going to prove it as we dive into unlocking the code in the classroom. We're going to pull back the curtain and look at some amazing lesson plans based on the BBC's Wonderblock series. Our goal? To uncover the secret logic of programming. Yep, that fundamental computational thinking that's hiding in plain sight inside the games young children play every single day. So let's start with the absolute basics, the two pillars of pretty much any set of instructions you'll ever follow: sequence and repetition. First up is sequencing. I know, it sounds kind of technical, but all it really is the art of putting things in the right order. Step 1, then step 2, then step 3. Every recipe, every set of directions, it all relies on this simple idea. And check this out. The hop lesson brings this to life. Kids aren't just jumping around randomly. No, they're actually running a simple program, a sequence of commands. Hop forward, hop left, hop right. They're physically feeling what it means to follow instructions in a very specific order. Now, building on that, we have repetition, or what programmers call loops. And this is a huge deal. It's a massive shortcut. Instead of writing out the same instruction 100 times, you just say, hey, do this thing 100 times. It's all about being efficient. The Moo lesson makes this concept, well, pretty hilarious and easy to get. The instruction is to moo, and the loop is just how many times you do it. Moo 3 times. Boom, that's a loop. The kids learn that some actions are meant to be repeated. Okay, so we've got order and we've got repetition. But what makes code feel smart? Well, that comes down to making decisions and knowing where to go. So let's look at conditions and direction. All right, this one's a real game changer. Conditional instructions. If, then statements. This is basically the brain of the whole operation. It's what lets a program make choices. If this happens, then do that. It's that simple. And the Cluck lesson teaches this perfectly with a sorting game. The rule is the code. If the block is red, then put it in the red basket. The kids are physically running a conditional program, making decisions based on data, in this case, the color of the block. So cool. Next, how do programs even move around? I mean, whether it's a little character in a video game or a real-life robot, it needs to understand directional commands. We're talking up, down, left, right, forward, back. The basic language of getting from point A to point B. The moving up lesson turns this into a super fun physical game. One kid gets to be the programmer, shouting out commands like move forward or turn left. Another kid plays the robot and has to follow those commands exactly. They're learning right then and there how to give precise, unambiguous instructions. So, what happens when things go wrong? Because, let's be real, they always do. And that brings us to one of the most critical skills in programming, and frankly, in life: debugging. Debugging isn't about failing. It's all about problem solving. It's just the process of finding the bug, the little mistake in your instructions, and figuring out how to squash it. It's kind of like being a detective for errors. And the Splot lesson has this brilliant way of reframing it. It's not a mistake. It's a game called Broken Robot. The teacher will intentionally give a wrong instruction in a sequence, and the kids have to spot the bug and shout out the fix. It actually makes finding errors feel like a fun team activity. Let's just walk through a quick example. So the plan, right, the program, is clap, stomp, jump. But the broken robot does clap, spin, jump. The kid's job is to debug it, find this spin, realize that's the bug, and replace it with the right instruction, stomp. It's simple, it's powerful, and it's a ton of fun. And finally, let's talk about the absolute bedrock of all logic. Some things just have to happen before other things. This is all about prioritization. Really, this is just about understanding that some steps depend on others. You just can't do step B until step A is finished. In coding, they call this the order of operations, and if you get it wrong, the entire system can just fall apart. And the first things first lesson uses the most perfect, unforgettable example: socks and shoes. I mean, you can't put your socks on after your shoes, right? It just doesn't work. It's such a simple, physical truth, but it perfectly explains a fundamental law of programming. The order really, really matters. Okay, so let's tie all of this together. Let's see how these simple playground games map directly onto the core ideas of computer programming. Think about it. What a programmer calls sequencing, these kids just experience as hopping along a path. Loops are just mooing a bunch of times. Conditionals become sorting red and blue things. Direction is just telling your robot friend where to go. Debugging is fixing a silly dance move. And prioritization, well, that's just knowing you have to put your socks on before your shoes. It's all the exact same logic. So you see, these aren't just kids' games. They are the absolute fundamental building blocks of computational thinking, and they're being taught without a single screen in sight. And that really brings us to a final thought. Now that you can see the code hidden away in the classroom, where else are you going to start finding it in your own life?